Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC2003 Physical Chemistry Lab. Today we're going to discuss on another experiment which is on the kinetics of chemical reaction, and that particular reaction is on the iodination of cyclohexanone. Now let's recap on what we understand on kinetics on rate law. Now suppose if you have a balanced equation which consists of the reactants A plus B giving you the product C plus D. The rate of this reaction depends on the concentration of the reactants at a certain order of reaction. So it depends on the rate constant times that of A over N and B over M, and these two are called, N and M are called the order of reaction, and K is the rate constant. So a rate law shows the mathematical relationship between the reaction rate and the concentration of the reactants. So, and this exponent N and M show the order or dependence of the reaction with respect to each reactant, and K and N and M can only be found experimentally. And in this particular experiment, you will find the values of this via the this iodination of cyclohexanone. Okay, in what this experiment is asking students to do. So you have a series of iodination of cyclohexanone experiments, and this is conducted in a water bath to make sure that the temperature is constant, because of the rate of reaction is temperature dependent, so you want to keep the temperature constant. If you do it in a cooler in a cooler ambience is going to be different. If you do it in a hotter, temperature is going to be different. So that's why it's very important to do it in a water bath. Alright, so the overall reaction can be represented as, here you have the cyclohexanone, and in the text or in your lab manual that is symbolizes as the word S, as the letter S. So you have here the triiodide ion, which is I3-, and that gives you these two iodocyclohexanone and hydrogen ion and iodide ion. Okay, now as this reaction proceeds, the concentration, you will expect that the concentration of the reactants will decrease, and on the other hand, the concentration of the products is going to increase. Now it's possible to follow the reaction by measuring this any of the reactants or product concentration as a function of time, but we can actually simplify things because by choosing the most convenient measurement, because in this case we can actually look at we can monitor this reaction by observing the loss of color in the reaction mixture, as you have this I3- react and disappear. And so since this is actually, the starting is actually reddish orange in color, so when so at the starting point, okay, so and all the other reactants are actually colorless, so you can actually take this as, you know, your main monitor. Now on top of that, you need a quantitative measurement. So in order to do that, you need to quantitative measurement in terms of monitoring the color change. So that's why you use a spectrophotometer to actually allow you to measure the absorbance of the visual light of this absorbance of this I3-. So the I3- ion will absorb some colors of visible light, allowing only this reddish and orange light to pass through. Okay, and so as the concentration, so you expect that as this concentration decreases, the amount of light absorbed will also decrease as well. So then you can actually use that to this relationship between the absorbance over time, you can use that to actually find the rate constant and also the order of reaction. So this is actually the series of the iodination that you're going to do. So you have 4 different trials you have to prepare. So in the first at the starting of the experiment, so you have here, you have the cyclohexanone mixed with HCl and distilled water. So you put that in the water bath. So you have the Ki3. Don't mix that, because the moment you mix that, okay, the reaction starts. Okay, the iodination starts. So because you want to monitor that. So the gist of the experiment is, so you put all this in a tube and immerse it in the water bath, and have a separate tube with Ki3 in there. And once you're ready, so you need to pipette this amount into this mixture, and then quickly you take some sample to actually start measuring the absorbance at an interval of 2 minutes. So that's how you do the experiment. Okay, now, so you have 4 trials, and this may not be the best values that I actually like, but these are not just values that you should just do it blindly. Okay, so if you're in the lab, you should look at what's going on here, because what's going on here, if you go from trial 1 to trial 2, the stark difference is that you're going to reduce the amount of Ki3, the I3 minus here. Okay, as you go to trial 3, so everything is constant, but now you're reducing from, if you're taking from, I'll take this as the main one, because everything is 4 here. So going from here to here, you're actually reducing the amount of HCl here. That means the H plus. Okay, now, and if you look at this the 4th trial, so you will see that everything is the same, but you're reducing with respect to 2 and 3, 2 and 1, so only the reduction of cyclohexanone. So this is wrong spelling. Anyways, so what's the point? So you need to monitor in terms of what happens when you keep the 3 parameters constant and the rest being changed. So that is the whole point, and see whether that has an effect. Okay, so yeah, and interestingly, we have here HCl. We're looking at HCl as well, although in here it is actually, you know, part of the product here that you can see here. So anyways, we will so that's something that you want to talk about when you do the discussion. Okay, so the absorbance of I3 minus is measured using a spectrophotometer every 2 minutes interval. Okay, the rate of direction is obtained from the slope of the plot of absorbance versus time, which you do every 2 minutes. Okay, so initially the concentration of I3 minus is high, hence you can expect the absorbance to be large, and as it progresses, so it becomes colorless, so you can expect it to be, you know, the reaction has already completed. Okay, so what next? Okay, I show you this again to remind you what's going on. Now, given that you're given a given data, all right, and it is found that by actually measuring the absorbance versus time, it is found that the trial 1 gives a rate of reaction of minus 0.00026. Okay, and this one gives you 260, and this one gives you 0.000230. This one gives you, so it will be nice to have a 0 here so you see the consistency. So then this gives you 0.000168, 0.000139. Now what I want you to actually be to discuss on, okay, how is this, how do the rates of reaction, what does it say about the rates of reaction with respect to the trial that you have, the volume of the stock solution. So I want you to look at the rate, and I want you to also discuss, in terms of whether you're adding or reducing, what does it do? So that's something that I want you to discuss in the lab report, okay? To see that if this is the trend that you will get for trial 1, 2, 3, and 4. So what's going on? So how can you relate this and this? Okay, please answer that as part of your discussion. Now the second thing is that, okay, now that you have that values, you're also given in the text that the differential rate of equation is given by this K, and you have the epsilon, and you have here this L, and you have this the concentration of this is cyclohexanone, the I3 minus and the H plus. Okay, so if you rearrange the equation, then you're actually solving for K. Now it is found also in this particular data that A is equals to 1, B is equals to 0, and C equals to 1. Okay, now the question that you need to answer, okay, what does that mean? What does it mean that when A is equals to 1, B is equals to 0, C equals to 1? What does it mean with respect to this, this reaction? So that is another question that I want you to answer as well. Okay, this is given as such. Okay, now so the differential rate equation is given by that. Okay, so this is also based on the, because you're using spectrophotometer, so this you can actually get the values via this Beer-Lambert law. So this is how this is actually tied together. So in terms of the process, okay, what you need to do is actually find, now that you have the values which is given previously here for all the rate of reaction for each trial. So you have the values for each trial, so you know the values is 1, 0, and 1 for the order of reaction. So you can find this value via by measuring the absorbance of the I3 minus with respect to its concentration. So for each trial you can actually find the values of the rate of reaction. So you have 4 trials with 4 different rate of reaction. So ultimately what you need to do is actually find the average of the rate. Okay, so this you're not asked to do that because we don't have the data here, but your assignment is to actually, just to remind you again, your assignment for this lab is to connect, okay, to explain how is this related to the volumes that's being used here. Second, okay, what does it mean when A is equals to 1, B is equals to 0, C is equals to 1? So that's given with respect to this experiment. Okay, and this is just to show you how the rate constant is being calculated. Okay, so this is a very interesting experiment. Unfortunately, we are not there in the lab physically to do this. So this is a picture that shows the change of the mixture as it progresses. So you're going to get from this brownish orangey to, as it progresses, you will get here all direction when direction is complete. So you have here a colorless solution. Okay, so now this is a very good video which I really want you to watch. Now it's not cyclohexanone, but it's a ketone as well. So this is a rate law determination of iodination of acetone. At the same time, there's also an extra determining the activation energy via changing the temperature. You can actually watch that. So I'm not going to show it here because it's quite long, so I want you to watch this in your free time in the midst of preparing for this lab. But watch this because then you will understand, because the concept is the same. Alright, the idea is the same. What happens when you actually keep the other concentration of the trial constant and you change one of it, and how does that change in terms of the rate? Alright, so this is actually the QR code for the YouTube. Alright, because I give you in terms of the PDF. So yes, so that's it. So you have here as usual, the report contains all this. Now, so your part is to discuss on the reaction and the tables that you have to relate to. Also explain what does it mean, the order of reaction, and the final thing you need to answer is you have 3 mechanisms proposed in your lab manual. So which mechanism does the reaction follow? So please answer that too. Okay, so this is due on the 19th. Alright, so that's it. Thank you very much. So we'll see you next week. Take care. Assalamualaikum.